Welcome to Maths with Bob. Today we're looking at the 3-minute series on statistics, and we're looking at hypothesis testing again with problem 2, another two-sided test where the variance is, well, it's actually known, and we're going to do some inferencing on the mean of the population. And you can have a quick look at the problem. We've got 100 students. They're asked how long they studied each week and gave responses which had a sample mean of 492 minutes. Now, if we take the population standard deviation to be 30 minutes, okay, examine the hypothesis that the students studied longer than 8 hours per week on average, and having a look at the 5% significance level. Now, I'm also going to have a look at the 1% significance level just to show you that this result is actually is actually very significant. Okay, so let's have a look. Okay, so what do we do? Well, first up, we set up the test. The null hypothesis is that, in fact, the population mean is 480 minutes. That is, on average, they studied for 8 hours. 6 8 is 48. Okay, and the alternative hypothesis in this case is a two-tailed one, and you can see here not equal to 480. Now, we're using our Z statistic again, X bar, okay, sample mean minus population mean mu. Okay, which we're just going to have a look at. See, it goes 480, and sigma, which is the standard deviation of the population, which is actually 30, and the sample size is 100. Okay, and our Z statistic actually turns out to be just a nice number 4. And prior to this, I actually haven't explained why we actually use Z levels of 2.5%. Well, it's two tails, right? The 5% is actually broken up into the 2.5 above and 2.5 below, and the 1% obviously is 0.5% above and 0.5% below. And you can see here roughly 95% lie within 2 standard deviations of the mean. It's a bit less than 2 standard deviations, you can see here. Anyway, let's have a quick look at the answer. Okay, so what happened? Well, at our statistic of 4, Z statistic 4, we're rejecting it actually. You can see the Z statistic is up here, well and truly out of our confidence interval ranges, which you'll look at next shortly. But so our statistic is not acceptable, basically. It's very unlikely that that's the case, you can see here. And even at the 1% significance level, which is, you can see here, 2.576, we're also going to reject it as well. So this is actually very significant. In fact, what this is saying is that, okay, our sample mean is miles, well, not equal to 480, obviously, with the 492, well, the sample mean being 492. And basically, what we need to do, we need to bump up the standard deviation up to about 60 before we're going to even accept it. Okay, so anyway, thank you for watching, and bye for now.